In our previous tutorial of Model Context Protocol, we introduced the MCP architecture and explored MCP servers in detail. Today we will continue our MCP journey by building an MCP client using Streamlit. We'll cover MCP client components and Streamlit fundamentals to create an interactive web interface for AI-powered tools, where users can enter their topics of interest and choose between two MCP servers, DeepWiki and Hugging Face, to retrieve relevant resources. DeepWiki specializes in summarizing codebases and GitHub repositories, while the Hugging Face MCP server provides access to open-source datasets and models related to the user's interested topics. We will break down the development process into essential steps, from setting up your development environment and securing API keys to handling user input, connecting to remote MCP servers, and displaying AI-generated responses. If you would like to read the blog post that covers these concepts in more details, please check out the link in the description. Firstly, let's set up our project directory using a simple structure where app.py stores our main Streamlit application script. Install necessary libraries. We need Streamlit for building the web interface and OpenAI for interacting with OpenAI's API that supports MCP. Use a requirements file to specify the library versions for reproducible installations by running pip install our requirements.txt. Secure your API keys using environment variables. When working with LLM providers like OpenAI, you will need to set up an API key. To keep this key confidential, the best practice is to use environment variables to load the API key and avoid hard coding it directly into your script, especially if you plan to share your code or deploy your application. To do this, add your API keys in the .env file using the following format. We will also need Hugging Face API token to access the remote MCP server. In the main app script, you can load these variables into your application's environment and makes them accessible as the operating system environment variable. Now let's explore the simplest way of establishing an MCP server-client connection. With the growing popularity of MCP, an increasing number of LLM providers now support MCP client implementation. For example, OpenAI offers a straightforward initialization method. To connect the client to an MCP server, you need to implement a connection method that takes either a server script path, for local MCP server, or URL, for remote MCP server, as the input. For example below, we are connecting to a remote MCP server DeepWiki that is deployed online and accessible through a URL. Now that we understand the fundamentals, we'll encapsulate MCP client functionality within a web interface using some simple Streamlit methods for enhanced user experience. We'll start with our initialize page function. This function sets the page icon and title, and ensures the overall web app layout is aligned in the center. This function returns a column object underneath the page title where we will place widgets in the following steps. Next is the getUserInput function. This allows users to provide their input by creating a text area widget. The height parameter ensures the input box is adequately sized, and the placeholder text prompts the user with specific instructions. Then we have the createMCP server drop-down function. This gives users flexibility to choose from different MCP servers. It defines a dictionary of available MCP servers, mapping a label like DeepWiki or Hugging Face to its corresponding URL. Streamlit's st.radio widget displays these options as radio buttons for users to select from. This function returns both the selected server's label and its URL, which are required for generating model responses. Now let's look at the generate response in more detail. This function extends the basic implementation by passing several custom parameters. First, we select a model that fits our budget and purpose. Different models offer different capabilities and price points, so choose accordingly. Next, we configure MCP server tools based on the user-selected MCP server URL. Since the Hugging Face server requires user authentication, we also specify the API key in the tool configuration and display an error message when the key is not found. Then we prepare the input text, which combines the user's query with tool-specific instructions to provide proper context for the model. The user's input is then sent to the LLM, which leverages the selected MCP server as an external tool to fulfill the request. We display the responses using the Streamlit info widget. If no responses are produced, we return an error message. In the final step, we need to create a main function that ties all functions together to set up our interface and gather what the user wants to do. Then it creates a button that, when clicked, triggers the generate response function. Before calling generate response though, it checks if the user actually entered any text. If they did, it shows a spinner while processing to give visual feedback. If no input was provided, it displays a warning message instead of calling generate response. This prevents unnecessary API calls that would consume tokens and cost money. Finally, a standard Python entry point ensures that our main function is executed when the script is run. Open your terminal or command prompt, navigate to the directory where you saved the file, and run streamlit run app.py. If you are developing your app locally, a local Streamlit server will spin up and your app will open in a new tab in your default web browser. Alternatively, if you are developing in a cloud environment, such as AWS Jupyter Lab, replace the default URL with this format. We have covered the steps to create an MCP client. As the next step, you can find the GitHub repository in the description. Implement your own MCP client and explore your Streamlit MCP client by trying out different topics. Thanks for watching. If you find this video helpful, please like and subscribe for more upcoming videos. Look forward to see you in the next one.